Okay, howdy folks. So this is the topic, workflow automation in microservice architectures. And this is a good visual of that, two animals fighting. And animals are a theme generally of presentations I give. So, and this is me. I am, of course, this one here. I am Niall Deehan, often confused with my pal there, who is Niall Deehan. It's a shame, really. So I've actually done a lot of microservice talks before, especially with workflow as well. It's kind of a thing I quite enjoy. And generally speaking, with microservices and workflow, first of all, does any who here knows what microservices are? Oh, great. And okay, great. So that's that one covered. Okay. Does anyone know why we use microservices and workflows together? Okay. No, yeah, pretty okay. Okay, good news. That's about there. And do anyone know how to combine those two? How to combine microservice and workflow engine? Oh, okay, kind of a dodgy number there. Okay, so let's try and focus this presentation a bit. So we're going to do something like this. We're going to spend a lot of time on. We're going to basically say very quickly what we are doing, why we do it, but more importantly, how you actually do this, because there's lots of options. First of all, a little bit of groundwork. Generally speaking, with microservices, your goal is you actually want to have this monolithic thing broken up and turned into some little services, and those services have really important little rules, like for instance, each one should have its own user interaction, let's say, its own service calls and system calls, and its own database, which is great, because it means that then you have complete autonomy in every service about what kind of technology they get to use, how to scale them independently, and this is usually a really good idea. And if you're very, very lucky, you might end up something like this, where you have all your services are all very, very happy and all independent, and they do not rely on each other in anything. There's all sorts of microservice rules, and people generally quite like this system. They quite like using architectures like this. But if we were to ask people what they have problems with regard to this kind of architecture, and we did, we have some answers. And those are, we got a 69% here. Oh, I don't have a laser pointer, shame. We got 59% say that they have problems visualizing end-to-end stuff. This is not uncommon. If things get quite complex, they tend to be like that. And also error handling can be an issue. About half the people we talked to in this survey had problems with error handling. So this is always best illustrated by a slide that I really like showing, which is this one, which is when you have lots of different microservices that are all independent and they all get stuck into a nice architecture, generally speaking, we like to think of it as kind of like this. Choreography is what it's called, where everything gets to play nicely together and everything works fine. This, of course, is not always the case because from my experience, generally speaking, guys don't always play well together. And another big problem, of course, is that we actually don't know what is happening. There's a whole big mess in there. People are fighting. It's very, very sad. If we take a very simple example, being this thing right here, which is Bernd, our co-founder in Camunda, created this really nice example on GitHub, which has 3 services. We have checkout, inventory, payment, and shipment. We want to do something very, very simple, which is someone says, I want to buy a thing, and it subsequently runs those. Okay, it makes sense. And that's quite nice. Those guys are totally independent, so they shouldn't need to rely on each other too much. And generally speaking, we suggest doing something like this. Okay, this is another service. This is the order service. And you can see here that it's got a really simple thing here. It's got, we place our order, we send a command for payment, we wait for a receive of that command, and then we send the next command. Okay. Now, this is creating a orchestration process, essentially. Now, it's important to remember that this doesn't necessarily violate a microservice principle. If you were to think of microservice principles, they say that every workflow must be owned by one microservice without exceptions. I totally believe in that. It's a really good idea. We shouldn't have to have a service like this that does more than just orchestrate what's going on. Problems start to happen when you end up actually calling something an order service and it's doing way more than that. You end up with something back to SOA-ish thing where you have this big blob that's doing a lot of stuff. So generally speaking, when we have an orchestration process, what I tend to see might be something like this. Okay, and this is a problem because we load our customer data, we check our credit card. Now, all of these might be independent microservices, but they're no longer in charge of their own destiny. They can't really control what they do because every little interaction needs to progress state to this orchestration thing. So that is a big problem because then you have a lot of domain stuff. You're actually kind of, the banded contexts are kind of mixed up. You don't really know where should I actually put certain, like the 2-week timer here, for instance. Is it part of inventory or part of the orchestration process? So that's generally why we like to say this thing here is a process which is in charge of just orchestrating the microservices, not in charge of doing any sort of work beyond that. And so then you're wondering, well, what about all the fun stuff that we had here? How does that actually progress? Well, there's loads of ways of doing that, one of which would be just add that process to that microservice. So specifically an engine as well, maybe it needs to hold state for some reason. So here we receive our payment, we use our customer credit card, and then we have the ability to basically do rollbacks and all sorts of stuff, all embedded here in with the microservice. So, and this is really important. This is all just part of BPMN, and it's also separate from the order process itself. And that is kind of a fundamental thing. In event-driven architecture, which is kind of what I want to talk about now, is when I quite like this event-driven architecture. Who actually uses event-driven stuff at all? A few, okay. Okay, so it's relatively new to combine sort of orchestration with event-driven things because people seem to think that event-driven is orchestration. But the basic idea of event-driven stuff is really simple. If if anything makes some kind of noise, it produces an event, and then you're just basically waiting for a notification on that event, and then you act on that. So it's a publish-subscribe sort of thing. There's lots of technologies around to do that. I specifically like actually the idea that we could both take these events and lots of other things can be triggered off the same events. It's really, really handy, and it can be asynchronous as well. So in that scenario, we have, with event-driven architectures, what we tend to see is peer-to-peer event change, or choreography is what it's also called. And in that case, I'm going to stand here because it looks like there's blank space, so this might be easier. Yeah. So what we see here is our checkout, let's say, item at this point. We got the same option. We just want to press that button and get to here. Great stuff. So that means that once we have the checkout, we place an order that creates an event. That event is then picked up by payment. It does some stuff. It then creates another event on some bus of some kind, which then gets picked up here. Great. Then we actually complete that. We send another event. This thing is waiting for that event, and therefore we now have a lovely chain of microservices. And this allows us to be able to do all sorts of really fun stuff with regard to synchronizing all sorts of services together. The issue, of course, is that we no longer actually have a view on what happens from a diagrammatic point of view, or at least an overview. Because as soon as you start using events and publishing them, it is wonderful to be able to publish an event and have loads of stuff pick it up, or having a microservice publish an event and that microservice not even care what picks it up. That is great. It's really quite useful. The problem is, if they doesn't care about it, we actually have a big problem when it comes to actually overviewing what happens. And I think we showed in the last two talks as well that actually seeing what happens in your process, even if it's a distributed system, is really important for improving it. So, and this is not something that's necessarily just like propagated by me. Martin Fowler in 2017 said, Martin Fowler being very big into microservices, he would not like that I'm mentioning his name in an orchestration talk, but he says the danger is that it's very easy to make nicely decoupled systems with event notification. And then he went on to say, without realizing that you're losing sight of the larger scale flow. He kind of is telling us exactly what the problem with microservices are, and despite the fact he doesn't quite like the solution. So you set yourselves up for failure in future, and there's actually lots of ways in which these can fail, because the first sentence is important. It is very, very easy to get started with event-driven stuff, because you have these independent things, they send events, you pick them up, it suddenly becomes very, very easy. But you actually need to balance out some problems that might happen. So the things we want are the loose coupling, we want autonomy, and we want event collaboration. That's actually what we're looking for. But unfortunately, we also need to ensure that we have end-to-end views of the process. That becomes much harder. We want to meet business SLAs. As soon as you start breaking stuff up into completely independent systems, it's much harder to know how long did it take to get from one point to another, for instance, or how long does this service take. And of course, this is kind of the most important one, support continuous process improvement. It was a big deal in the previous talk as well, and it's also kind of fundamental. If you have a small service set up that's doing all sorts of event streaming, that is actually great, wonderful. But if you want to add to that, or more importantly, change it and improve it, you immediately come into things like versioning problems. If something is maintaining state at some point in your microservice, you're then going to have an issue when you change another one that has a whole different front end. How do you deal with those in-transit stuff? So we actually recently went to a Kafka summit in London. And these guys essentially are kind of linked to this architecture. They have an event bus right down here in the middle, and this is Kafka. And what they tend to do is, with event-driven stuff, they tend to put their microservices there that are just either listening for events or publishing events. And so to drop in and say, okay, we now are going to essentially say to you, you need an orchestration flow for this. It's very, very hard to sort of drop that in there. The architecture basically works. They haven't really come across the problems yet. So what we did was originally, we essentially just said, okay, well, here's what you would get with what we can do. What we did was we connect a workflow engine to the event flow. So just simply have a workflow engine that's not actually producing any events. It's just picking them up. It's a broadcast. It can pick them up. So what does that mean? It means that we're saying, okay, from now on, for every event that happens, we're going to create a model. Okay, and we're just going to say when that event happens, we will just correlate that to a state progression within the workflow engine. And what that means is you end up with loads of these. These guys still don't even know that they have a workflow engine involved, but what they get is they get actual data about what's happening in their processes, even if they haven't built them yet. So what we're just doing is we map essentially the event flow as it happens to a simple process that just shows what should happen in what order. It's very, very handy. It also suits the microservice sort of thing, because what they get to do is they say, okay, well, it's independent. I can add this to my architecture without even changing what my microservices are doing. Kind of handy. Now, what ended up happening was this is important, but now they actually realize that there is more to it than just seeing what has happened, because stuff you can do with with BPMN means you can actually sort of have the state maintenance thing and add one additional thing, which is add the ability to send events under certain conditions. So let's say that we have reached a certain state, let's say. Now we know we've reached that state because we picked up these events as they happened, and the engine itself holds that state, and it knows it's been 14 days. This is a non-interrupting boundary timer event, obviously. I don't have to tell you guys. I'm sure it's one of your top 5. It is not one of my top 5. It then basically goes and sends an event that is essentially saying, I don't know, kookaburra or something, whatever it says to Kafka. And that thing gets picked up, and it then can tell other systems to do a thing. It's very nice. It's only dealing with state, and it's saying, now I will send events based on state alone. And that's really easy to do and doesn't involve messing around with your microservices too much. It's a nice way of adding it. And how am I doing? Ooh. And who thinks I can talk faster than this? So we have that nice little order thing. So now what will happen is, now if we added this lovely thing here, we get one more great addition, which is under this scenario, which is quite nice. We have this lovely event, but now let's say we actually want to change things slightly. We want to fetch the goods before the payment. Really, really simple. Now, this is where the argument switches around. In the previous argument, I was saying, you don't need to change anything. It's really easy. Everything stays the same. But if I throw it back at them saying, let's imagine that you didn't have a workflow engine. Instead, you just have your regular event streaming, but now you need to make that change. Okay. Well, now they need to change a whole bunch of different services, because they now need to actually switch those two around, and then they need to actually change a whole bunch of microservices just because they want to change the orchestration. Now, this is where we start to actually build some sort of common ground, because this is a problem. Changing your microservices in the order in which they happen is very, very complicated if you do not have some kind of way of orchestrating stuff. Which is why it can be sometimes quite convincing to say, well, what if instead of you sending your message that is going to be picked up by another microservice, let's just imagine the services are basically going to be picked up by the engine. And depending on where they are, it will decide on what happens next. And it then produces a command that says, here it is. And the way that changes, because if I wanted to change this thing here, it's really simple. I add a parallel gateway here, and I can then wait for two things in parallel. When they both come in, I can, send two things in parallel, and then wait for two things that might come in. So I can then say parallelizing systems and also waiting for stuff to return. We now have the ability to say, okay, we're waiting for stuff to happen, but we're now in charge of commanding what happens next. So it makes it very, very easy to actually switch the order of anything because you own the orchestration. So now if an order is placed, it goes to order. Order realizes what this is and sends a receive payment thing to the bus. Okay, and now we basically it listens for the event and it decides to issue the command. So that means that these guys are no longer. They have to talk to a service anyway. You have to choose the coupling that you're going to have. You're either going to be coupled to a specific choreography or you're going to be coupled to an orchestration service. It's both coupling, and one of them has some advantages and others don't. So this is going to be a shocking sort of slide, but yeah. So generally speaking, if you have a distributed system, you basically are using microservices. I don't think you need to specifically say that I follow all the paradigms of microservice architectures. Well, I got 5 minutes, no problem. And also you can have state recorded and maintained right there. That's actually an important thing because state in a currently changing architecture means that if I have the state here, I can also version stuff because Camunda has versioning, which means if I want to change the order of things, I can deploy a new version while the previous version is still also working. So it means in-flight communication, those events are still picked up and still run on the old version until that version fades out. All new things will start in the new version. We even have migration and stuff. That's only really possible if you have a dedicated orchestration layer. Okay. I'm losing time, so I want to mention this slide because it's really important because part of the BPMN specification and part of having an orchestration is, this is actually in my top 5 symbols, for anyone wondering. It's compensation. It's a really, really cool thing. Who here uses this in BPMN? Yep, got one big fan, good stuff, front row, very good. So what happens is, we start here, we do this thing, okay, which we need to do. We then, maybe in some cases, need to receive payment. And if we charge their credit card and there's an error, we have this little thing here. Now what does that mean? This thing is a state machine, which means once I hit this, it's basically saying, look through the state of this process, whatever has been successfully completed and has this symbol, run the corresponding task. That's really important because in some cases, you might have a long process in which some things have been completed, some have not, some have been skipped. But if we own the state and we know what's happened in the past, it's really easy to implement compensation because we own exactly what happened previously. Okay. So where are we? Yes. Now, one thing I want to make it very clear is this orchestration thing isn't coupled to any specific communication. I'm using Kafka as an example because a lot of people tend to do that. But actually, this might be REST, it might be messaging, it could be an event bus. It actually doesn't matter because it's independent of that. The engine itself just maintains state. It doesn't really care what kind of system you're using for communication. I've implemented this with messaging and REST and service buses and stuff as well. So, yeah, so the typical way, how long have we got? Yeah, we're almost there, 2 minutes. Okay, so the basic idea, we could have our message bus in there that connects to our payments, or we could also have an order service that makes calls. The important thing is the banded context. As long as the order service is the one making sure it does the orchestration, and these guys are doing the work, you actually won't end up with some problems. Now, one other architecture I want to suggest purely selfishly is this one, which is where you actually have a workflow engine sort of as the bus. It's a little more complicated. I've seen it before. People really don't like that one, but in microservices. But I think it's pretty handy because then you could still have the independent services own their processes. They just have an engine in the center for the orchestration part. Okay. So there's actually, because the Camunda engine and workflow engines in general are relatively lightweight, you can actually place them kind of wherever suits the architecture. In some cases, you actually might have a completely independent engine at each microservice. Also perfectly fine. Now, why would you do that? For state maintenance, for versioning, for compensation, all the things I mentioned. It doesn't need to be for orchestration. You could also actually connect these guys to one. And what you actually get if you use a use a workflow engine embedded here, as well as everything else, is monitoring, which is, again, a really key component. And that can be done through either dumping all the information to Elasticsearch and commenting on it, or using something optimized that Furby showed earlier. Yeah. So let me see what I got. I got an important slide. There we go. So we basically have a good example of this already. This you'll find this GitHub repo where we actually have this Kafka monitoring thing if you want to get started. If you're already using microservices, the fact is Kafka, as I said, is not massively relevant, but you can essentially have a model that represents exactly what's happening in your process without needing to actually get in there. But it should be the first step towards realizing that actually having a dedicated orchestration service could actually be really, really useful in making bigger microservices. Because I think as Martin Fowler said, it's actually very, very easy to create very small chains. It gets really complicated the more changes you make and the more improvements you want to make. Okay, and that is exactly 12, so thank you very much. And